Exercise 1.3 problem 1 discussion. If A and B are two sets and U is a universal set such that n of U equal to 700, n of A equal to 200, n of B equal to 300 and n of A intersection B equal to 100, find n of A complement intersection B complement. So this is what we are asked to find, and we are given n of U, n of A, n of B and n of A intersection B. Am I right? So from this problem onwards, this exercise we will do a short discussion where we will list out what is given, what is asked, what is the formula connecting these two, and what are the steps. And thereafter I will suggest you to pause the video, try to work this problem on your own, and on completion come back and check the solution. Because the earlier exercise problems were simple, straightforward, so we didn't apply this method. Okay. So what is given in the problem? N of U is the 700, n of A is 200, n of B 300, n of A intersection B is 100. And what are we asked? We are asked to find n of A complement intersection B complement. What is the formula? I hope you remember De Morgan's law. According to De Morgan's law, A complement intersection B complement is A union B the whole complement. Or n of A complement intersection B complement is n of A union B whole complement. So instead of finding this, if we find A union B whole complement, we will be able to get the value, right? And but what is n of A union B? We have a formula for that, the cardinality formula, which says n of A union B is n of A plus n of B minus n of A intersection B. Okay, if you look at this, n of A we know, right? It is given here. N of B is given. N of A intersection B is given. So if you substitute all these three, we will be able to get n of A union B. Once you get n of A union B, you should be able to get n of A union B whole complement, which is, I've missed to list it out. It is basically n of U minus n of A union B. That is n of A union B whole complement. Once you know A union B complement, that is what we need to calculate as per De Morgan's law. Okay. So what are the steps? Substitute the values of n of A, n of B and n of A intersection B in this formula. N of A union B equal to n of A plus n of B minus n of A intersection B, and get n of A union B. As I told you, we know this, we know this, we know this, right? Substitute and get n of A union B. So next step will be to calculate n of A union B the whole complement. So what is n of A union B whole complement? That is n of U minus n of A union B. A complement means that needs to be subtracted out from n of from the universal set. So if we have n of U is 700 and suppose n of A union B is 200, n of A union B complement will be 700 minus 200. Okay, so we will be able to calculate n of A union B using this formula. Right. Once we know n of A union B whole complement, we can calculate n of A complement intersection B complement using De Morgan's law, which according to it says n of A complement intersection B complement is nothing but n of A union B the whole complement, and that is what we calculated in step 2. So whatever is calculated in step 2 becomes the required answer using De Morgan's law. Okay, so these are the steps which we need to do. What I suggest is you pause the video here and try to work this problem on your own, and then come back and check your working against our solution. Okay. Okay, now I'm coming to the solution. So we list out what is given here: n of A, n of B, n of A U, and n of A intersection B. So we have the formula. N of A union B is n of A plus n of B minus n of A intersection B. Substitute these values. N of A union B will be n of A 200 plus n of B is 300 minus 100. That is n of A intersection B. So that is 500 minus 100 is 400. So n of A union B is 400. What's the next step? We will have to calculate n of A union B the whole complement, which is, okay, actually there's a small correction. Actually I should come here. Okay, but I have done it this way. By De Morgan's law, this is what is asked. N of A complement intersection B complement is n of A union B whole complement. Okay, So De Morgan's law said A complement intersection B complement is A union B the whole complement. But we want to find n of A A complement intersection B complement. So that will be equal to n of A union B whole complement. So we need to calculate this, but that is equal to this by De Morgan's law. Now, how do we calculate n of A union B whole complement? That is n of U minus n of A union B. Do we know this? Yes, we know. We calculated it here. N of U, it is given in the formula, that is 700. So substituting that, we get n of A union B the whole complement as 700 minus 400, that is 300. Right? So n of A union B the whole complement is 300, which is n of A complement intersection B complement as per equation 1. By 1, we get n of A complement intersection B complement is n of A union B whole complement, which is 300. Right? So that is the value of this n of A complement intersection B complement. To summarize, okay, first we find n of A union B, right, using n of A plus n of B minus n of A intersection B. Then you find n of A union B whole complement using n of U minus n of A intersection minus n of A union B. Then apply De Morgan's law, which says that n of A complement intersection B complement is nothing but n of A union B the whole complement. Using that, we will be able to get the value. Okay. So I hope I made it clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.